Let's solve LeetCode's 26th question, that is remove the duplicates from a sorted array. So you get an array with a non-decreasing non-arranged with the elements arranged in a non-decreasing fashion. Okay, so basically a sorted array, and what you have to do out here is find all of the duplicates and replace them and remove them basically, and you have to do it again in house. In house means in place, which means that you don't use any extra array over here, right? So there's no external memory usage, and you just do it within the same array and you return the same array that has been inputted to you. Now how do we go about this? The way we're going to do it is using 2 pointers. How do we do it using 2 pointers? Well, first thing, you initialize the 2 pointers at these locations. Well, actually you initialize them on the second location. You'll understand why in just a little bit. How you start about do this? First thing we do is we check for the previous element, and that's the reason we're starting from here. If we had started from index 0, the previous element wouldn't have given us a segmentation fault error, because we're accessing some sort of an illegal memory, right? And so that wouldn't be possible. So we start from the first index and we check at the 0th index, or the n minus 1 or I minus 1 index. And what do we check? We check if, well, let's just say that the array is called nums, and so we check if nums of I minus 1 is equal to nums of I. Now if that is the case, so if this is the case, what will we do? We will know that these values are the same, so it's a continuation. So that is where we leave the j variable and we anchor it down to this index, and we increment the I variable. How do we increment the I variable, and as in what fashion do we increment it? We increment it until we find a new value, correct? That is not the same. So there is this. What do you do over here? You increment the I value else, which means that the numbers are not the same. So for instance, like this, in this case the numbers are not the same, correct? So what do you do in this case? You swap out the I and j index values. So you say that the array of j is equal to array of I, and then you increment I and you increment j. Now let's understand what's going on over here. Once you increment I and increment j, your I and j will obviously move in this fashion. And what you did to do before that, you replace this value with the value over here. So this value becomes this value. What happens to this value? Nothing, because we haven't changed anything. There's only one operation over here. Now again the same old fashion repeats all the way until I reaches the end. So that's your condition for your while loop, correct? So you wrap all of these things into a while loop and you say while I is less than nums dot size. You keep doing this, and what they have asked us to return is the number of unique elements in the array, which is, as it so happens, 5. Now let's just go ahead and dry run this entire thing in a clean fashion. Okay, let's just move this all to the side, and let's get back to this. So first you have I and j like this. Now I and I minus 1 index are same, so I increments to here. Same thing, I minus 1 index is same, I increments over here. Now this value and this value are not the same, correct? So this value of I swaps with this value of j, so 2 comes over here and this becomes 2, and I increases, so I increments to here and j increments to here. Same fashion, these two values again are the same, so you move on and you get I over here. Now this replaces this, we have 3 over here, I increments, j increments. Now further these two values are the same, so again I increments. Now again these two values differ, and so your 4 moves to 1 over here, and so your j comes here, your I goes here, and your 4 comes here. Now notice that the length of the array has been crossed, and i's value is equal to now nums dot size, right? And the condition for our breakage was I is less than nums dot size, and so our value now, our loop now, it breaks and we exit. Once we have exited, notice the value of j. J is there at the index 0, 1, 2, 3, 4, 5, and that, as it so happens, is the number of unique values, and that is how our algorithm is structured. The number of unique elements will always be the value of j, and that is what we will ultimately return. So once you have exited this outer function, you return j, and that is it. Thank you for watching.